Thank you for the invite. My name is Robert, Rob for friends and colleagues. I work as a business analyst for Alphabet International, and today also with me is Tiese. Tiese works for GROUP9, and GROUP9 is helping us in the project that we are going to present to you today. But before I get to that point, I first quickly want to tell you something about Alphabet. Alphabet is a business mobility provider, also called a leasing company, and we're 100% daughter of the BMW group. I paused there for a minute because this might be the moment that you realize you're not at a Google presentation, but please bear with me. We think we have an equally interesting story to tell you today. And besides that, the name Alphabet was long used by us before Google decided it was actually a really great name. And you can Google that. We offer light commercial vehicles, bicycles, bikes and passenger cars of all brands, so not just BMW. We are present in 28 countries, some with affiliates, and we hold top 4 positions in 9 European countries. We serve almost 90,000 customers, and we have over 750,000 vehicles on the road. Our mission is to become the leading provider of outstanding business mobility, and the way we want to do that is by designing flexible and innovative solutions to optimize your mobility. I share this with you because this is key to the project that we are doing. The project that we're doing is a strategic project in order to get this realized. And you can also see from this that it's not about getting as many cars on the road as we can. It's about serving as many customers to get from A to B. And that means it's no longer just about the car. It's about making sure that you have an easy and comfortable way to travel from one place to the other, whether it is with a car, whether it is with a bicycle that you pick up from the railway station, or whether that is with a public transport card, or a combination of all that. And it's this that is actually fundamentally changing the business as we have it today. Now, some of the solutions that we offer, first of all, there is the funding of vehicles, which is the classical operational lease, financial lease, sale and lease back. And we offer a lot of mobility solutions around the vehicle, which is maintenance and repair, insurance, roadside assistance, that sort of thing. These are the 2 classical components of our business. But what is coming to it is advanced mobility solutions. Things like corporate car sharing or a mobility budget. And a mobility budget means instead of getting a car from your employer, you get a budget from your employer that you can spend as you like. And that can be on a leased car, but that can also be on a public transport pass or anything else, or a combination. And if you like to have things more luxury and comfortable, you can spend a little bit of your own money. Whereas if you save money, you can put that in your own pocket as an employee. Now, it's these advanced mobility solutions that also pose a bit of a challenge for our current business. The systems that we use in our markets are monoliths, and they are centered around the car. And with the new transition that we see, it is actually more about the customer and its mobility needs. And the challenge that we have is that with those monoliths, it is actually every small change that we do is actually time intensive and costly. And that is the reason why we started with this project. So we see that we have a challenge, that mobility is fundamentally going to change, and our current software is not able to handle it. And at the same time, even though we know our business is changing, and we know that it's no longer about the car, we have no idea how that future is actually going to change. We have no idea what will happen to our business when the autonomous driving car will ever become a reality, for example. So what we needed is a platform that was built for change. Something where we know that we can adapt things quickly and at relative ease. Something that is easy to connect, easy to use, easy to change. And based on modelless services. I think you call it microservices. I'm a business person, we call it business services. They're more or less the same thing. They're centered around the capabilities. And the important thing there is that we want to be able to change or even completely replace certain modules without big disruptions for other services. We also made another important decision, and that is that we want to be back in the driving seat, to just use an automotive metaphor there for you. We know best what our customers need, and therefore we also think we know best how our products should look like. And we do no longer want to be dependent on IT for our core services that was actually not built by us. That does not mean that we do not work with external suppliers anymore. I mean, the reason that we're here is because we use Camunda. It just means that for the core applications in our business, we want to be in control. Now, there is a couple of reasons why we have actually chosen Camunda in our project. And I work at the BPM department of Alphabet, and we saw that we have a number of objectives that we could realize with Camunda that are very close to our BPMN mission statements. One of them is consistency from business to execution. I don't think it will come as a surprise to some of you that even up to this day, we keep running into situations where the process on paper is different from what is actually happening on the work floor. With Camunda, for the first time, we have an integrated chain, and me as a business analyst know if I look at that process, that is also the process that is happening. The other great thing that it does for us is that we discovered we have now created a common language between our developers, IT, and the people working in the business. It was not just BPMN. I have to say it's also because we introduced domain-driven design and event storming, but also BPMN really now helps us to see what is it that our developers are doing, and at the same time for me as a business analyst to communicate what we want the system to do. And it has been a great improvement to how we did development in the past. What we also want is flexibility in updating our workflows. We are a financial institution. That means increasingly more we have to deal with compliancy, and that means that we need to introduce and that we need to incorporate that into our workflow. The problem we have now is that it is very time consuming, and we end up with a lot of manual 4I principles, and I can tell you it's a nightmare for our business. And we want to go towards more self-serving and straight-through processing. And even though what we build now sometimes contains service tasks, because where a person still needs to key something in, at least we have a good overview now where we can replace those service tasks while we continue with the platform into system tasks. And that, again, that is a great advantage of how we used to work in the past. And the last thing, and this is something that is really close to my heart because I'm also a black belt, is that we like to benchmark our processes and also optimize the processes based on those benchmarks. At the moment, the information that we get from our market, if we get anything at all, is very heterogeneous. We can't actually compare it, and if we do analysis, only the analysis itself takes a lot of time to processes, and we then not even are to the point that we can find root causes and optimize it. We have not actually introduced optimize yet. However, we do have a license, and I personally have great hopes that once we get the platform further, that we can also really use it for improving our business.
So I'd like to tell you something about how the system itself that we work on is structured. First of all, what the view is on how the business is segmented. Rob already mentioned we have defined a set of high-level capabilities on how the business actually operates. And a service becomes a service by the fact that it offers operations that you can do. You can think of this as a place you can go to literally in the business, say, hey, can you now do this for me? And whatever they need to do, they will do for you. Examples, there are a couple here. The way we agree a contract with a customer, but also when we run that contract, how we actually operate it, including any changes, because yes, even if you have a contract for 4 or 5 years, you might have changes along the way. The famous example of adding a tow bar to your car because you find out you actually need to pull a caravan, stuff like that.
Very important in the Netherlands.
In the Netherlands, for sure, yeah. But also the whole process of managing our assets. These are examples of things that we do there. And the way we translate this into our technical components, and you'll see a lot of similarities to what Niall just told, is that we do that pretty much one-to-one. A business service is a microservice, and this allows us in the technical part to follow the business very closely. The way the business is organized is also the way the system is organized. It gives us physical deployment separation. It allows us to work on these services independently with multiple teams. But especially because we can deploy these services independently, we can also meet some of our scalability requirements, for instance. If you zoom into the way these services themselves are organized, we make a distinction between the parts of the service that actually do things, that perform behaviors, and the way we can look at information in those services. And this allows us to have a very small set of functionality for doing things in the system, and a wide array of ways of looking at that information, pulling in information from other contexts to look at it. Even so, we do still have a very complex domain. And to address that, we also employ, Rob already mentioned, domain-driven design, which is a way of putting your domain at the heart of the application. And especially because we want to move towards more straight-through processing, having a rich domain model is more or less the only proven way of scaling the amount of business logic you need in your system, as opposed to coding it all in your use cases. So we have few models in a microservice. We have commands. They both utilize the domain. That gives us the context, the bounded context that Niall also mentioned, of what a certain part of the business is all about. At the same time, using a hexagonal approach, you can abstract from a couple of technical capabilities of the application itself. And this allows you to more easily evolve the domain, test it, experiment with it, and that's all part of the domain-driven design philosophy of finding out all of the complexity in the domain and putting it actually right there. Just to give you an idea of the kind of technology we run this on, we do everything in EE8. We connect with a Postgres database, and our apps that we write for users are written in Angular. We package that. We run that on Payara Micro and package it in Docker. It's run on an OpenShift environment, and as a communication technology, we also have Kafka in that same environment available. But of course, you can imagine, and Niall already had the same example more or less, the actual business process that we're thinking of more or less traverses all of these services. And it uses different parts of our business to actually fulfill something for a customer. And the way we approach this is to follow the same model that we have with the other parts of the application. Process becomes a capability of a service. That part of the business that handles these kinds of things, that part of the process, is allocated straight with that domain that handles all of the details of it. Technically, we end up with this picture because that's where Camunda comes in. Technically speaking. We embed a Camunda engine in each of our services that needs to handle at least part of a business process. We deploy our process definitions as part of the software, so they're just packaged with the software and they get deployed when we start the service. We do share some code on how to bootstrap the engine and stuff like that, just for reusability, which you can override, but otherwise it's just a matter of embedding the engine in the software and getting that process flow, or at least that part of it, exactly where it belongs with the domain it belongs to. And there you can see that we already get some of the objectives in the picture, where we can actually look at what's going on in our business by executing it in those individual services, and we also have the state management, obviously, that comes with Camunda to do that. A service, just to give you an idea, more or less consists of these parts. We write apps, which we deploy on pods. That's just the unit of deployment in Kubernetes, but OpenShift is a Kubernetes implementation. The service itself with the process capabilities in there, and separately we deploy an instance of Camunda Cockpit to be able to look at that part of the business processes that's going on there. They obviously look at the same database. Apps and services may be scaled. Cockpit is typically not used day to day, so we don't need to actually scale that with the service itself. With these view models and commands, we actually use the straightforward Java API that comes with Camunda. We don't use the REST API or anything like that. The view models and the commands connect directly to the Java API that's available in the service itself. To allow users to interact with this, we write our apps in Angular, as I said. We do traditional taskless applications that we write using the API, and they communicate over REST in our case. But we also do more specific things where, for instance, we have a context view. You're looking at the contract for a customer or an offer we made to you. And based on that context, we know there's actually a process running that has a task that you could complete. Or there's a signal, a document upload, or something you could do here, assuming it's a manual thing that we do there. Using the flexible API that we have, we can offer this kind of way to perform your work directly in that context for the user. So we combine these two approaches. And a lot was already said about orchestrating microservices, and I hope I'm not contradicting too much there, but I don't think so. We still have this issue of all these services that perform part of the process, but the process as a whole we still need to do. The first thing we do is typically find out which service is actually end-to-end responsible. It may be a separate service, but it might also be an existing part of one of the ones we already have. And we allocate the end-to-end process in there. It doesn't mean that it does everything itself, but those things it can do with its domain, so it can perform commands, it can react to events that happen there, is orchestrated within that service itself. If it can't fulfill some work itself and needs to instruct somebody else to do it, another part of the business is invoked by invoking an operation on that other business service that performs that part of the process in the way it knows it needs to be done over there. And a lot of times we're obviously also interested in, these are synchronous calls, by the way, in our case. We do REST calls. That's the way we communicate these kind of commands. We're also interested in a lot of cases in the results that come out of that, and we choreograph those using Kafka. So events are emitted from other services to notify of results, and the orchestrating process can consume those. There might be other consumers as well, but this is one of the typical cases that we see. Here you can also see, Rob already mentioned, one of the objectives is to have flexibility in changing workflows. Having those parts that really belong to a specific part of the business in those services allows us to change it there. If, for instance, in invoicing we decide that we now want to do stuff differently than we did before, we can, because we can just go into the invoicing part and change that part of the flow, as long as it still complies with the contract it has with the other processes. Because we do explicit management, we don't do event, let's say, peer-to-peer event chains. We want to have this overview of how the actual process is executed. So we do a combination of both. Then we still need to find this common language to talk about this. It all starts off with an idea of what a part of the business should function like. And one of the very first things we start doing is an event storming session. Can I see a show of hands for event storming? Anybody familiar with event storming? One. Just one. Okay, at least one fan. I won't go into detail about event storming itself, but it's a workshop technique, and what we do is we get business analysts, we get developers, testers, product owners, subject matter experts, everybody in the same room, and we figure out, by defining the events, what actually happens during this process. And that gives us a rough structure of the important things that happen when this process is executed, whether it's in software or not, doesn't really matter. With that structure, we not only get the events that happen there, but also we get a very good idea of which interactions we might have, for instance, with external parties or with other services internally in our landscape. And when we start detailing that, and for the one person that knows about event storming, there's this notion of a policy, and a policy in event storming is a detailing you can do of the event chain, where you find out what is actually the let's say, event to command transformation that happens. That's exactly what the process itself is responsible for. If this happens, then we need to go do this. And that's what we start detailing when we start working with the event storming model and detail it into a BPMN model. There we have the exact interactions between all of these services, and everybody in the room now understands what we're talking about and how the process is actually executed. And then we can move to the execution itself, where we actually execute it with Camunda, and there you can see we come full circle, that we get the insight from the operations into, hey, this actually doesn't happen that efficiently, we can now start optimizing this process. For the technical people in the room, this is a way this works with all of that hexagonal stuff there. Let's say a user issues a command using a UI somehow. And that's in domain-driven design, there's the notion of an aggregate. And I again won't go into details about this, but you can think of this as the collection of information and behavior that you can execute within that domain. So a command is executed on an aggregate, which may result in an important event, one of the events from the event storming, which the process actually picks up and responds to by executing a different command on the same or a different aggregate. There may be multiple. View models can be updated based on events that happen as a response to a command being executed. But an aggregate can also go out to an external system using what is called an anti-corruption layer and issue a command there to have it perform there. But you can also think of this as this is a way that you can direct a different microservice to do something for you from your context. There may be events coming back, and this is the kind of pattern that you see within a service, how all of these things come together. That's all still traditional, let's say, control flow, but then in the microservices context. I'd like to tell you a couple of things about some more specific ways that we use Camunda. First of all, with aggregates, which in DDD terms are actually a transactional unit. So you always retrieve the whole aggregate and you store it as a whole. And the way we mimic this in our system is to actually do document storage, in our case in Postgres. Yes, that does have native query performance, if you were wondering. So we store a JSON blob in Postgres as the aggregate information. But of course, the structure of this aggregate might change as we evolve the domain. We find out that there are more details we need to add, or we need to change something, or the business has evolved somehow, so we need to change something. And since we have a zero downtime requirement, we need to somehow upgrade all of the old documents, so to speak, the aggregate representations, to the new ones. And the way we plan to do this is by having batch processes running in Camunda with lower job priorities than ongoing work, where in the background, after the redeployment of the software, we will actually upgrade these aggregates if they're not used, because obviously if they're used, they're immediately upgraded. But that's a way that we intend to use Camunda in the future, near future, I should say. Also, there was a question before about technicalities in your workflow. We actually have the same question. How do we deal with this? We have a couple of systems we need to interact with that have, let's say, interesting characteristics. I want to do one thing, but it requires me to do 5 separate calls asynchronously and poll for results. But on the business process, I don't really care about this kind of stuff. Or we need to throttle our load that we place on an external system. We need to retry things, schedule them, stuff like that. All these kinds of things that Camunda can do very well because it has this state management capability. The way we do this is by using call activities, which use a technical flow within the same service. So there was the point before that it becomes quite hairy if you try to actually do call activities between contexts, but we're talking about a technicality within the same service. And we sync all of the technicalities we need to do into that separate flow, so we still have the observability of what's going on. We can intervene if we need to. We can retry things, but we don't see it on the business process level. So that's one way that we use Camunda as well. When we started this project, we weren't yet sure whether we would have multiple instances of the service because we operate in each of these different markets, or we would have a multi-tenant system. So we started off with a single tenant system that now has to become, after we have a decision, a multi-tenant system. Unfortunately, in Camunda, there's no API to do this. There's no way to say, hey, I have a process instance here that's not aware of any tenant information. I would like to switch it to a tenant that I've now identified. So with the consulting group of Camunda, we came up with this approach to introduce this in an in-flight system where we first start off with new instances that we start with a tenant, then we start evolving the automated tasks into tenant-aware, then we switch our task handling apps, and hopefully by the time we have to introduce our second tenant, we will have everything completed. Otherwise, we will have to resolve to a database migration, which we also have lined up just in case. But by doing this step-by-step approach, we hope that we won't have to, and we also won't have to introduce everything in a big bang, make everything tenant-aware in one single go, which is obviously not very agile. With tasks, we also have a couple of specific things where I'm talking about user tasks. I think that's clear. We want to have this insight into the way the operation is running and how to improve it. But first of all, we need to start thinking actually in tasks at the modeling level. A lot of the systems we have are quite traditional in the sense that they're really focused on data entry. So first of all, we need to start thinking of what is the actual change you're trying to enact as a user and define those as tasks in the processes, but also run any change in our system through a business process. There are no changes that don't run through a Camunda process. That's our goal. This also helps us that we have these task-specific models that we can now define. You remember from before we had these separate view models. We can define view models specific to a certain task, which we can also throw out if we change the task and we don't need it anymore. So that gives us a lot of flexibility. We have certain requirements for security of tasks. It's not only sufficient to make sure that only an authorized user can access a task, but also execute certain commands or view certain information is restricted to the user that actually claimed the task. And the way we solve this technically is by issuing separate JSON web tokens when you claim a task that are used to then access the view models and commands that you saw before. And it was interesting to see the previous customer case where they're talking about documenting some of these things internally on how they use it. We actually do the same. We found out that it was very helpful to have an internal resource on how we actually use Camunda. Not necessarily on what you can do with BPMN, there's lots of information there. We also trained our people to at least have this basic level of understanding. But especially the way we use it and to be able to discuss those things and reference them, we also created an internal resource where some of the patterns and guidelines that we use are also available for everybody. Some things we ran into, quite maybe just interesting to mention. We hit a snag with multi-instance sub-processes where we didn't realize at first that if you have a return variable from a service task, it's not assigned to the instance of the multi-instance, but to the multi-instance as a whole. Very easily found on the forum, by the way, and solved by looking at the information there. For database migrations, we have an issue because we have all of these separate services, and at the moment there's no automated way, if you upgrade Camunda, to actually upgrade the database structure that is beneath it. So we're working on our own solution to actually upgrade this because it's obviously it's unworkable to go into every single microservice and do a SQL update manually on that service when you do a release. That's just not going to fly. So we're working on an automated solution there. Testing-wise, with this version we used, I'm not quite sure about the current one, but JUnit 5 support was not in there. Yay for open source, because we just looked at the code of the JUnit 4 test rules and wrote our own extensions to be able to test. The testing assertions that come with the community extension, they clashed with our version of assert.j, so that's something else we bumped into. But a couple of days ago we had the 7.11 release, and once we can do our database upgrade, we can then also upgrade our Camunda version, and then we have the integrated test assertions available, so we're looking forward to that. Also, with all of these services deployed, Cockpit at the moment, without doing too much magic, is mainly capable of looking at one process engine and the information in there. So we can't really see the end-to-end business flow. I understand there's something in the works there as well in the process monitoring tool, so we're also eagerly awaiting what that will look like to see whether that can help us in that regard to get that full picture without having to code all of it ourselves. And another point that I actually put on the slides but has an update, and that was actually yesterday or the day before maybe even, we ran into the issue that there's still some BPMN support that's not in the framework at the moment. You can't do escalations on user tasks and errors, which is valid BPMN-wise. And we had a feature request for that, and that's actually planned now for a future release. So we're happy that's coming too. On the modeling side, orchestration in Camunda Modeler is awesome. Choreography of all these different services is, obviously you can model it in an orchestrated way. BPMN choreographies are not supported at the moment. That's one of the things we feel would be a great addition, especially for our case, if we could use the standardized way of modeling choreographies. I know there's a community project there, but it doesn't really integrate well with the modeler. So we're hoping that maybe something comes up here. I already mentioned the forum. We had great feedback on a couple of questions. We also provided some feedback and answers ourselves. And we also were able to look at some of the extensions that are already there, work that has been done before, and take some interesting information from that. We were in contact with Camunda a couple of times for support, and not only was that very helpful, but I'd like to thank the people I was in contact with, because it was a lot of fun working with Camunda directly as well. That's all we have. Thank you very much. If there are any questions?